Welcome back. Today we're going to start Block 5, Topic 2, Lesson 2. But before we do, I want to go back over some of the problems that seem to be the most challenging on the Kahoot you were asked to do on Monday. By kind of skipping a day, it gives me a little bit more time to let more of you finish your work and to evaluate what you've done. Well, there's nothing there. All right, so this was one that I noticed several of you missed, and you were to find the number that makes the equation true. We're using a lot of the skills that you've already built this year, and one of those is just your multiplication facts. So you've got to stop and think, what would you do to 3 to change it to a 9? Since the numbers get bigger, we know that we've got to multiply. And the thing is, whatever you multiply the denominator by, you have to multiply the numerator by, because you want that value of 1. So 3 times 3 is 9. So 2 times 3 would be 6. So 2/3 times 3 over 3, which gives you that value of 1, which doesn't change the value of your fraction, just changes the way it looks, gives an equivalent fraction would be 6/9. Okay, this was another one. You'll notice that the numbers get smaller. So when the numbers get smaller, we've got to divide. 24 would have to be divided by 6 to get 4. So 42 divided by 6 is 7. And my guess might be that you missed that because that is a tougher fact. Again, since we're dividing by 6 over 6, that's the same value as 1, and it doesn't change the value of the fraction. Now, the true or false ones are the ones that got kind of tough. So you also had to check and see if this is a true statement. 4 times 3 is 12. Is 7 times 3 21? And if you don't know your facts, that makes this a lot harder. 7 times 3 is 21, which makes this one true. Here's another true and false. You would probably know that 5 times 5 is 25. 6 times 5 is not 36. This should be 30, which makes this statement false. And then the ones that had 3 in it, those were even more challenging. So if we look here, 3 times 3 is 9. 3 times 5 is 15. You go back to that original fraction. So we'd have to take 4 times 3 to find out what was equivalent. And 4 times 3 is not 13. So this one would be false. This would need to say 12 instead of 13 to be true. When I look at this one, the numbers are getting smaller, so we're dividing. Again, this could be a challenge if you don't know your facts. So I'd start down here at the bottom. 9 divided by 9 is 1. So 72 divided by 9 is 8. And then this goes back to what you know is 8 over 1, the same thing as the whole number 8. And you should know that 8 over 1 is the same thing as the whole number 8, which makes this one true. So those were the ones that I noticed were the most missed on Monday. And I hope this quick review helps you because we're going to use this skill in what we do new today. So this is that skill that we learned in lesson 1. You'll notice that the 4 is smaller than the 8, so we have to divide. To change the 8 into a 4, no, using your facts, it's 8 divided by 2. So you need to do the same thing for the numerator, 6 divided by 2, to get that 3. You'll notice that we're dividing by 2 over 2, which is a value of 1, and the fraction pieces can be used to prove that this is a true statement. Today, you will learn to compare fractions by finding equivalent fractions with common denominators. And I don't normally play the videos when we're in our lesson together, but since so many of you aren't in Block 5 already, I feel like I need to go ahead and do that. And I'm sorry I can't enlarge it because my screen recorder won't work. So please listen and follow along. When you get ready to submit your answer, you need to type in, submit to me. When you click turn in your work, just please let me know that, let's write like math 180 video. And that, if you submit that to me, I'll know that you did this assignment and didn't just click turn in.
Use equivalence to compare fractions. At the health department, Kate tracks illnesses at the city's schools. She receives a report that many students have head lice. To track the lice outbreak, she keeps records of the fraction of students at each school. She sees that 7/12 of students at one school have lice, while 5/8 of the students at another school have lice. She wants to compare the fractional part of the school's students who have lice.
Ew, lice!
So, we need to compare 7/12 and 5/8. These fractions don't have common numerators or common denominators. We can't compare them to the benchmark 1/2 because they're both greater than 1/2. But we also can't compare them to the benchmark 1 because they're both less than 1. So we need a new way for comparing these fractions. Let's review our work with fractions and the skills we already have. If we find equivalent fractions that have the same denominators, we can compare them using a strategy we already know. First, we'll make a list of multiples of each denominator. When we find a value in common, we can find equivalent fractions for 7/12 and 5/8 that will have a common denominator. We'll list a few multiples of 12, 24, 36, and then a few multiples of 8, 16, 24. From the list, we can see that a common multiple of 8 and 12 is 24. That means we can rename both 5/8 and 7/12 as fractions with denominators of 24. You probably know that 12 times 2 is 24. Remember that you can write an equivalent fraction by multiplying the numerator and denominator by the same number. So we'll multiply the numerator and denominator of 7/12 by 2 and see that 7/12 is equivalent to 14 24ths. 8 times 3 is 24. So we'll multiply both the numerator and the denominator of 5/8 by 3 and get 15 24ths. Now we have fractions with a common denominator, 24, that are equivalent to our original fractions. When fractions have common denominators, we only need to compare the numerators. 14 is less than 15, so 14 24ths is less than 15 24ths. And so 7/12 is less than 5/8. So Kate knows the school with 7/12 of its students with lice had a smaller fraction of students with lice than the school with 5/8 of its students with lice.
Still gross.
Renaming fractions with common denominators helps us to compare any two fractions and helps Kate compare the fraction of each school's students who have head lice.
So now, not only will you write M180 video, let's put in there that this was about lice, and that way I know you'll actually have participated. You saw an example on the video. We're going to do an example together. We'll compare these two fractions using strategies you already know. Both fractions here are greater than half and less than 1. So we can't use those benchmarks that we've normally been using. So that leaves us with either the common numerator strategy, forgive my abbreviations here, or the common denominator strategy. They don't have a common numerator or a common denominator, so we really can't use either one of those yet. We need to have a new strategy, and that is to make a fraction that is equal that does have a common denominator. So we want to make these have a common denominator using the skill of equivalence from yesterday. So from Monday, 5/6 and 7/10. So we stop and we think about what are the multiples of 6. So we've got 6, 12, 18, 24. None of those are going to be multiples of 10. And then we get to 30. I know that 30 is a multiple of 10. 10, 20, 30. So we want to change these so that they have a common denominator of 30. Using the skill from Monday, You know that you'd have to take 6 times 5 to get 30. So we multiply the numerator by the same thing. So we've got 25/30ths. To change the denominator 10 to 30 in the other fraction, we'd have to multiply by 3. So 7 times 3 is 21. So 5/6 is really the same as 25/30ths, and 7/10 is really the same as 21/30ths. Now with that common denominator, we simply compare the numerators, 25 and 21. 25 is greater than 21, so we'd put in the greater than symbol. So 5/6 must be greater than 7/10. If you have any questions or concerns, please just let me know so that we can meet and go over these. We'll try one more. As you do the practice, you don't have to show me all of these multiples if you don't want to, but I want to show you all of my work so that you understand what's going on. I know that 3/8 is less than half because 4/8 is half. 5/12 is less than half because 6/12 is half, and both of these are less than 1. So again, I have no other strategy to use other than finding that common denominator. That doesn't look very much like a D, but you know what I mean. So we're going to be looking for the multiples of 8 and the multiples of 12 to try and find the one that's in common. Multiples are just the answers to your facts. So 8 times 1, we're going to skip count by 8. 8 times 1 is 8, 16, 24, 32. I hope that's far enough. Now we'll do our 12s. 12, 24, and I don't have to go any farther. I know that that common denominator will be 24. So this is why I'm saying when you get ready to do your quizzes, you're going to need some scratch paper because you're not going to be able to think all this through without writing it down. And you'll know that I gave you plenty of time on your quizzes to do that. All right, so we want to change these to 24. To do that, I would have to take 8 times 3, and that's what's nice about this list here. You could count 1, 2, 3, and I multiply the numerator by the same thing, which is 9. I'd have to take 12 times 2 to get 24. 5 times 2 is 10. So 3/8 is the same as 9/24. 5/12 is the same as 10/24. I just need to look at the numerators. 9 is less than 10. I would put in the less than symbol. And so I can compare 3/8 is less than 5/12. In this lesson, we used equivalent fractions to rename fractions with a common denominator. Then we compared the numerators to determine which fraction is greater. You'll be practicing this either on the quizzes or doing the picture from the book that I've posted in Google Classroom. Have a great weekend. I look forward to seeing some great work.